Today we are going to be learning how to deploy our backend Node.js application on AWS and make it highly scalable using production-grade infrastructure. We'll be working with AWS ECS Fargate ECR and exploring critical concepts like load balancing, target groups, auto-scaling policies, CloudWatch alarms, clusters, and task definitions. Before we begin, here is an important warning. Everything we are going to be covering today has an hourly pricing on AWS. If you are following along for learning purpose, then make sure to delete or terminate all the services and resources immediately after completing this tutorial. Leaving these services running 24/7 can result in significant charges on your AWS bill. Only run the services continuously if you are deploying it to production with a proper budget. This was our notes application that we have built. Front-end runs on React and backend runs on Node.js. And then the front-end part, which is built on React, is also deployed in AWS Amplify, a highly scalable front-end application. But the remaining part that was left was the backend for our notes application. Since we have made everything as scalable, the last part that was left to make our backend scalable depending upon the load that we get. For this, we are going to be using AWS ECS containerization option. For that, you need to make sure that you have Docker installed in your system. If you don't have Docker installed in your system, then you will not be able to build the image or do the coding. If you are on Windows, you can simply download the Docker desktop option, or if you are on Mac, just simply download Docker, or if you are in Linux, do the same following. After you have installed Docker, you need to start the Docker. To know whether Docker is running or not, just open a terminal and type docker ps. Here, if it's showing this kind of response, it means that Docker is running in your system. Or you can also run docker ---- version. It will give you the version of Docker that is installed. Now, for this tutorial, you don't need to know much about Docker, Dockerization and everything. If you don't understand the Docker code, then that's not a problem. You can simply copy and paste that code. It will work. The main objective for today is building a highly scalable infrastructure that can automatically scale depending upon the load it gets. So for this was our backend, and we'll be deploying this Notes app backend only. First, we need to make it containerized. For this, first let's add a health route, because it's very important to have a route where we are going to be sending some request, and if server is online, then it should reply us with some response. For that, we are going to be having a get health endpoint. Let's do that. Here we'll basically have a health endpoint for our ECS. When we send to /health, it will just return the JSON status healthy and the timestamp of current timestamp to string. A simple endpoint, but this thing is very important because every time we need to check whether our server is healthy or not. If our server is not healthy, we can destroy that container and spin up new container. For that reason, this is very important. Now, here inside our Notes app backend, we need to write one more file. This will be our Docker file. It will be capital DOCKER file. Now here we need to write our Docker configuration. Here first, we'll be starting to write a multi-stage optimization Docker configuration. So first, we'll import Node22 Alpine image as builder, and then we'll set our working directory as /app. Then we'll copy all our package.json and package-log.yaml file. Then we need to install all the packages using pnpm install. But first, we'll be also requiring curl to run curl command inside our container. For that, we need to run this command, run apk add no cache curl and dependencies. Basically, we are installing curl inside our Alpine node image. This APK refers to Alpine package keeper. It's similar to sudo apt that you'll see on Ubuntu. Then we need to run npm install -g pnpm. npm will be already installed, so we need to install pnpm. Then we need to call pnpm install frozen log file. This was for our builder stage, and now we are going to be copying all the files that are there. Now we need to start writing our production stage. This time we'll again call node22 alpine, but this time it will be as production. We'll set our work directory as /app. Then again we need to be installing curl and pnpm, copy all the package.json and package.log.yml file to the current folder. Then use pnpm install to install all the packages and copy all the application code. And then we are going to be exposing it on port 3000. It can be any port that you want to expose, but since we are doing everything in port 3000, so we want to keep that default only. And then we'll run some health check. Like here we are setting the health check as interval for 30 seconds, timer 5 seconds, start period of 5 seconds, retry is 3. We'll be running curl -f localhost 3000 /health and then exit 1. For this reason, we have installed curl, and then we'll just call node index.js. For running our backend, we need to run node index.js, and it starts our port on port 3000. So inside our container also, we need to start our Node.js server by calling this command, and we don't need to have any process manager. If the server gets crashed, then it will stop replying to our health endpoint and this container will be automatically destroyed. So we don't need to worry about that. Now we have written our Docker file. Now some files we don't need to copy. Those files are needed to be ignored. For this, we'll create one more file. This will be .docker ignore. Here we need to have some files that we don't want to have it inside our Docker container. So these are some files that we don't want to have inside our Docker container. But you might notice that when I'm saving this, Prettier is formatting it in this way. And this is not the correct format for Docker ignore. For saving this, you can either disable Prettier for this time. Let me disable Prettier for now and restart the extension. Here we need to save it in this format only. Now our Docker ignore file is correct. You can simply get the repository code. I will link the repository so that you don't need to type the Docker file and Docker ignore file. You can simply copy it and paste it. Now we have written our Docker ignore file and our Docker config file. Let's build a Docker image now. For this, open the terminal. Navigate to the nodes backend folder. Here we have our Docker file, this one. Now let's build the image. For building the image, it's very simple. You need to run docker build -t and give any name of the image. Let me name it as nodes app local backend, and then just give a dot. And depending upon your internet speed and processes, it will take some time. Like it's just loaded from the cache, but in your case it might take time to download the Docker image first. My one is already downloaded because I used a lot of time. And now inside your Docker images, so this was the image that we have created. First we need to test it locally whether it's running or not. So let's run the image. Here we need to expose port 3000 to 3000 only. Let's run this. This is now running on localhost port 3000. Let's try to access localhost 3000. Here we are getting cannot get. Let's try to access /health. Here we are not getting any problem. Let's try to check. Here it's also not printing any error. That means that we had successfully built our Docker container and it's working fine. And now we can simply stop this. We need to test it first before deploying it to AWS, and it's working correctly in local. Let's start our next step. Here I'm on my AWS console, and first we need to have AWS CLI installed in our system. For this, I'm not going to be going to that tutorial again. If you want to know more about that, you can simply watch the AWS CLI tutorial. For this, you need to also have an IAM user that will have the permission for ECR full access. Like if you are creating a user, make sure to add the permission for Elastic Container Registry full access. This one will be requiring this. If I currently run AWS STS get caller identity, you'll find that I'm currently logged in with dev user, and I'm going to be adding this permission to this user so that this user can access and deploy code inside our Elastic Container Registry in AWS. So for this, first we need to search for Elastic Container Registry, this one. Now, from here, we need to create a new repository, but make sure to the region where you are creating, because if you create repository, let's say in US, you cannot access that repository in Mumbai. Since we are working with the same region for all of our previous tutorials, we'll be also choosing this AP South one Mumbai. Let's create a new repository. Here we need to give a unique name. Let's give the name as our Node.js nodes backend. Here make sure that images can be overwritten is selected, and then we can simply create this. Just created a new repository. Now we'll be calling view push command. Here first we need to do login. Make sure that you have AWS CLI installed and you have also provided this permission. Otherwise all this command will not work. Now we are inside our Notes app folder, and here we have all the files. Now let's first try to log in to our AWS console. Now we are logged in. Here it's showing login succeeded. Now we need to simply run this command. First, we need to build the image. It will take no time because everything is cached. In your case, it will take time. And now we need to just add the latest tag. And now we need to push our image from our local system to our Elastic Cloud registry. Depending upon your internet speed, it may take some time. Now we have pushed our image inside ECR. Let's try to close this and refresh this. You'll find that we just pushed the image and it's around 77 MB. Now, if you are getting any error, that means that you have done something wrong with AWS CLI or you have not configured IAM. Now, we need to search for AWS ECS Elastic Container Service. Open this in new tab. Here we need to first create a new cluster. You can name the cluster anything. Let's give some name, our nodes backend cluster. Here for infrastructure, we are going to be selecting Fargate. We don't need any monitoring or encryption or tags. We can simply create the cluster, click on create. Now it will take some time to create the cluster. We can view it in CloudFormation, open it in new tab. Here just complete our creation. Our cluster has been created. From here, you need to click on the task definition option. Click on create new task definition. Here choose create new task definition, first option. Here we need to give a unique name for our task. Let's give like nodes, node, task, def. Launch type will be Fargate. For architecture, I'm just selecting x86-64 because the laptop that I used for building the image was x86-64. So my Docker image will be also similar architecture. Here, 1 CPU and 3 GB RAM is too much. I don't need this much. So I will go with the lowest one. Like first I will select 2 GB and then go with 0.25 vCPU, and then I will go with 512 MB of RAM. This is the lowest that we can get. For task role, I will create a new role, and here we need to choose our container. The container is this container that we have created, our nodes backend container. Given the name as that. Now we need to select it from ECR. You'll find that it only shows repositories only in that region, not in other region. This was our repository select, and use this. Do not select image digest. If you select this, then every time it will choose the latest image automatically that you pushed inside your repository. So use this option, use image tag select, use image tag latest. Now it's okay. For port mapping, we were exposing our port in port 3000. Let's use that. Let's name it as node port, and app protocol will be HTTP. We don't need any resource allocation limits, but we need to provide some environment variables. If we check our backend environment variables, then we were using frontend URL and port. We need to provide this. So add environment variable, first add the port will be port 3000, and frontend URL, we can't provide the localhost URL since we have already deployed our frontend website inside AWS Amplify. We'll be using that endpoint. In our previous tutorial, we have already learned how we can deploy our frontend application inside AWS Amplify and get and also add a custom domain to it. So this was our final URL with our custom domain using this URL only. Here we can add the URL, but we will not be adding the slash at the end. Now this is our front-end URL. Now make sure to have this login, otherwise you cannot view the logs that are happening. For health check, this is very important. We need to add our health check. Like here it's suggesting cmd shell curl -f localhost and then exit1. But in our case, it will not be localhost. It will be localhost 3000/health. So let's do that. Just add this cmd shell curl -f localhost 3000/health and then exit. For this, let's use the default option. If you don't provide anything, it will use the default one. 21 GB is more than enough for us, and we don't need any monitoring or tags. We can simply create a new task definition. And now a new task definition got created. You can view the JSON configuration. If you add JSON directly, then you should be pasting that. Now, if you want to run a single instance, in that case, you should be running a single task. Else, if you want to make it highly scalable depending upon the load it gets, in that case, you should be creating a service. In our case, we need to create a service because our objective is to make it highly scalable. Let's create this, create service. We can give, let's use the random generated name. Here, we need to choose our cluster, the cluster that we have created, our Nodes backend cluster. For compute option, I'm selecting capacity provider strategy. For this, make sure to select Fargate, because if you select Fargate spot, then that's not good. Fargate spot is meant for tasks that execute for very less amount of time, like cron jobs. Now, let's scroll down here. For deployment configuration, it will be a replica, and we don't need to. And here deployment option, we can set minimum running task as 50% and keep this deployment strategy as rolling update. For networking, now we need to create a new security group. It doesn't matter what's the name of the security group, but we'll be requiring access to our port 3000 and it will be from anywhere. Also, we need the custom TCP for HTTPS for port 3 so that AWS can pull the image to that container. If we don't allow the access for this port, then it will fail. And for one more, we can also allow the access for port 80, because if port 443 fails, then the system might try to access port 80. So for that reason, we are allowing port 80 also. Make sure you can keep public IP as turned on. Next is our load balancer. Here we'll be using load balancer. Make sure to pick it. Here is our container name. Here we don't have any existing load balancer, so we can't choose any one of them. We need to create a new load balancer. Let's name it as Nodes Backend ALB, means application load balancer. And I had selected application load balancer. Don't select network load balancer. It's meant for different purpose. And then we need to create a listener. Listener will be on port 80. Here we also need a target group. Target on port 80. The registration delay 300 seconds. It's okay, but our health check route will be /health. We don't need to do anything to VPC lattice, but service auto scaling is important because our objective is to make it highly scalable upon the load. For this, we need to just select it. And since we are using load balancers, minimum one task should run, otherwise load balancer will fail. So one is minimum and maximum. You can provide anything. For this, I'm just not going too far. I'm selecting 5. For scaling policy type, we have two options. Either we can use target tracking or step scale. Target tracking is more easier to apply, but step scaling requires some advanced setup. Let's not choose that. Instead, let's use target tracking. Here, let's set it to CPU, average CPU utilization, and target value, let me set it to 25%. So you might be thinking, what's the meaning of this? The meaning of this is that if we get too much load, our CPU utilization might go higher than 25%. And if CPU utilization goes higher than 25%, then I want to add more containers. If CPU utilization stays below 25%, then it should spin down all the existing containers that we have. I'm selecting this as 25% so that I can easily show you how auto scaling works. But in your main production case, you should not be selecting 25%. Instead, you will be set something like 70, 75 or 80%. because 25% can be easily achieved. I'm just giving the name as set target CPU 25%. Now here we need to provide the scale out cooldown period. The scale out cooldown period means the time we need to wait before adding more containers. Now scale out means adding more containers. So for this I'm just choosing as 45 seconds because I want to make it very fast to spin new containers, and scale in means reducing the number of containers. For this I will be selecting 60 seconds, but you need to play with this according to your need. For this tutorial I'm showing so that we can spin up quickly and spin down quickly, but in your production case you need to decide the time upon your need. Let's create this service. It will take around 5 to 10 minutes to create. We can view that inside our CloudFormation. Like here it's creating the target group and security group, and all these things are getting created. It will take some time. Let's wait until it gets created. Now it's creating our ECS service, means it's in progress. Here we can see that here it has created a ECS service. Here we are getting the desired task 1 as pending. Let's check the task. Here it's showing it's activating. If here we get any error, then that can be problematic for us. Let's see what happens. Now we can see that our single task is running and it's healthy. It means that we have done all these steps correctly. Currently, it's only running. Let's verify the health and metrics. So it's utilizing like CPU is around 1% and memory is also around 1%. This is our load balancer and it's listening to port 80. Let's go to this load balancer. This is the A record. Let's try to visit this A record. Here we are getting the response as cannot get. It means it's correct if we try to visit our health endpoint. So here it's showing the healthy and also providing the current time. Let's see. So that means we had successfully deployed our container correctly, and this is our load balancer URL. For now we have done everything, but one thing that's missing is that if you go to the task and view this task, you'll find that the task role is this role. If we try to visit this role in new tab, then you'll find that it has the permission for EC2 task execution role policy, but since our container will require reading and writing data inside our DynamoDB database, for that we need to add the permission for that. Just click on add permission, attach policies, add DynamoDB. For this I'm just adding DynamoDB full access, adding permission, and now our DynamoDB can be accessed from our container here inside our front end that's running locally. Here in our backend URL, let's change it to the load balancer URL. Just add http:// load balancer URL, and now let's try to save. Here inside nodes node app task that we have created, let's try to create a revision for this. Here for task role, also set ECS task role. Like we have set to create a new task role. For that reason, we need to select none for first time, but now this role has been created and we have also added the DynamoDB full access role. So we need to just set task role as ECS task execution role, and now let's create it again. This time it was for task definition 2. We need to update our service now inside our cluster, our nodes backend cluster. Here we need to select the service. Here we need to update our service. Here we need to select force a new deployment. Task definition will be second one, the latest one that we have created, and we don't need to do any changes. Everything will be same like as it is going. Don't do any changes here, just click on update. Now let's just wait until it fully updates. Now as you can see that here it's provisioning a newer one. It will pause, it will remove this one after this one gets provisioned. Let's wait until this one gets provisioned. This one was our newer one that's running 1 minute ago, and this one has the task role as ECS task role, and Also the execution role, but this one does not have. But this one did not have the task role. It only had the task execution role. Currently, it's in the activating stage. So this container will be removed. Like let's click on refresh. This container just got removed. This one is getting removed. And now let's try to refresh. This time it was able to load our nodes. As you can see, it loaded the data. This one easily. Yes, so our nodes application is now working. Our backend is working successfully and we can do everything. Now let us test how much load will our backend can handle and how it can auto scale. But before that, I would like to show you one thing. Here, you need to search for CloudWatch. Here, visit CloudWatch, open it in new tab. Here, you need to visit the alarms. Currently, you can click on all alarms. Here, you will find we basically have two alarms. First one is the low alarm, and second one is our high alarm. Currently, just think that we had set the if our average CPU utilization goes more than something. So we need to scale out and add more containers. So that alarm is known as the alarm high, and this alarm that is in progress is known as low alarm. Here it's saying that if CPU utilization is less than 22% for 15 minutes, in that case, this alarm should trigger and reduce the number of containers. Now we can modify the containers, like 15 minutes is a lot of time and 3 minutes is also a lot of time. If you want to reduce the time, in that case, what we should be doing? Here currently we had set our high alarm at 25%. When it goes more than 25%, it should be creating more instances. So here we need to go to actions and edit. Here we need to do one thing like additional configuration. We need to set our minutes to 1, means only for 1 minute. If CPU utilization goes more than 25%, we should be spinning out more instances. Let's click on next and everything will be similar, and let's click on next and update the alarm. Here also for our low alarm, we need to edit this. 15 minutes is way long. We don't want to wait for 15 minutes. Instead, we can just add this for 3. It will be treated as 3 minutes. Let's click on next and click on next and next. And now we can update the alarm. We have updated both the alarm. Now, if we check all the alarms, we'll find if CPU utilization is less than 22.5% for 3 minutes, then this alarm will get activated. If CPU utilization is more than 25, then this high alarm will get activated. Now we have set the alarm for a very low period of time. If you do a load test for 1 to 2 minutes, in that case, you might be seeing that how many instances it's going to scale. Currently, if we check, we have only one task running and one instance that's running for 33 minutes. Let's send some load to our application load balancer and let's see how it handles and how our alarms create a scale in and scale out. So for doing load testing, I'm going to be using K6. If you don't have K6 installed, you can simply type K6 download and download it inside your operating system. It's free. It's a product for Grafana. So I have already downloaded K6. So I don't need to download it again. Here we need to write a new file. This will be load test.js. You will be calling this script using K6. So here I have just added a basic K6 load testing. First, we'll be testing with 10 virtual users for 45 seconds, then for 1 minute with 20 virtual users, and once more with 40 virtual users. We are considering if our response time is more than 500 seconds, it will be considered as failed. Here we need to just add our load balancer URL. The URL that we are going to be testing all the load is going to be base URL /health, means our health endpoint, this one. So for this, we need to simply call our load balancer URL and paste that URL here. And we need to run the script. Running the script is very simple. If K6 is installed in your system, like you can run K6 -- version. So K6 is installed in my system. Now I can simply call K6. Now we need to note what happens. Like here is our service. Let's try testing with load. For this, since we have set 500 milliseconds as the response time, it's required that you should have good internet connection for testing. Otherwise, if internet connection is not so good, this test might give wrong results. So let's use K6 run in the name of a file where we have written scripts. It was loadtest.js. Let's close this and make the screen more larger. Let's run it. So it's creating virtual users that are required. Let's see what happens here. Here currently we have one container running for 39 minutes. So the load test was successful with 40 users. It sent around 5,205 requests and 99% of them were succeeded. Only 11 of them failed. Means the 11 requests had more than 500 milliseconds of latency. That means that a single instance was able to handle this much amount of load, but now we need to increase our load so that we can hit more than 25% of utilization. We were only able to hit 7% utilization, not even 25. Let's increase the load. Now instead of 10, this time we'll be sending 100. Let's reduce the time to 30 seconds, send 200, and again for 30 seconds, 150. This time the load is going to be more. Let's save the file. Again run. K6 run load test. This time I think that will be hitting more than 25% of average CPU utilization. That will trigger us to scale more new containers. Let's wait and check the response. So test is now complete. So 100% of the request got succeeded. This time nothing fails. We were sending around 200 requests per second. Out of 22,000 requests, all of them just passed. So that's really very good. And how much we are able to hit? It was only able to hit 11% of CPU. Now let's try to increase more load. Let's make it to 500. Let's make it to 1000. And 750. This time is going to be bigger. Let's clear our screen. Again run, load testing script. Let's start. So this time it has started to fail. It means that this time it's going to scale. So now our test was completed. But the thing that was when we are sending 335 requests per second, but after 41,000 requests, it started failing. It means that we just hit the limit. So as you can see, currently it has 5 instances running. My internet connection is also not good. That means the 6% this amount of requests that got failed may happen. It was my internet issue. Like we hit 80% CPU maximum utilization and we were able to trigger the alarm and it started to scale 5 instances. And now currently you will find that 5 instances are running. It just turned out. It just started 4 minutes ago, 4 minutes ago. Someone was around 7 minutes ago, and another was 4 minutes ago. So that means you got the idea that this was our first instance that was running. After doing our second test, it just turned this instance on. And when we are doing our third test, adding too much load, it just turned 1, 2, and 3 instances. So for now, we have 5 instances running. Now currently we have 5 instances running. If we check the health and metrics, we find the average CPU utilization is currently, CPU utilization is this much, but average will be around 25 plus. And inside our CloudWatch alarm, if we check here, if our CPU utilization is low, in that case, we'll find that it starts to scale down because we had written the scale in logic also. So after 3 minutes, if CPU utilization is less than 22.5, it will start reducing the number of containers. Let's wait for that. So it started the CPU utilization. Now, as you can see, CPU utilization is starting to reduce. Now, if it stays for longer time, it will start reducing the number of containers. Let's wait and watch for some more time. If we go to the service, auto scaling service, here you will have these scaling activities. Like as you can see here, scaling desired count was set to 2 at this point, and scaling desired count was set to 5. Now, as you can check, here currently 4 instances are running. It's all because of the alarm that we have set. After every 3 minutes onward, if the CPU utilization started getting reduced, in that case, it should be decreasing the number of containers that are running. Now currently we have 4 containers running. After some 10 to 12 minutes, we'll see that we have only 1 container running. Like if we check the auto scaling service, here if we go to the scaling activities, here you will find that successfully set desired count to 4 as it's fulfilled by ECS. So from 4 it just set to, so from 5 it just set the count to 4. After some time we'll see that we are setting the count to 1. Now we have successfully learned how we can make our backend highly scalable. Now as you can see that it is keep reducing the count, like it just changed when it was 729 it changes count to 4, and now 31 it changed count 3, and now in 33 it just changed count to 2, and after some minute it will change count to 1. So that means you just got the idea how it basically scales. That currently only 1 is running. I think that yes. So now only 1 is running. Now if you check here, you can see that it just set to 1. From here we are doing the load test here. So it just changed it to 5 containers, and after some time it took 30 minutes to realize. Then it took around 30 minutes to reduce the CPU utilization to less than 22% for 3-minute interval, and then it started triggering an alarm and reducing the number of count, and now we only have 1 container that's running. Now this is our HTTP load balancer endpoint that we are accessing. But if we check that from our localhost, when we are calling our backend, you'll find that we are calling HTTP, and this gives a unsecure option, and this is also not so good to have HTTP endpoints. So for making this, we need to add our own custom domain, because AWS now doesn't provide HTTPS directly. For this, just open your domain registry provider. As previously you can see that we have already set our front-end nodes up. Now it's time to link with our backend inside the load balancer that is created, this one. Here we need to add one more listener. This listener will be on port 443, means it will be running on HTTPS port. Just select protocol as HTTPS, port will be 443. Here we can authenticate users, but we should remember one thing, that our backend is open for everyone, that anyone can access without authentication, and we are dealing the authentication in our authentication middleware in our backend, so we don't need to worry about that. So for this, let's keep this as unchecked, and here we need to select the target group as this one, target on port 80 that we have created recently. Here we need to request a certificate for our domain. So for this, I currently don't have any domain. Here I need to open this in new tab. First I need to verify my domain. Then I will get a free certificate from AWS that will be automatically renewed since our front end was www.notes-app.snehasis.com. So I will be keeping this as api.notesapp. Here we need to request a certificate, a public certificate. Public certificates are free. Here we need to add our full domain name. For this we can just copy this and paste it here. Instead of www, this will be API and we don't need to provide HTTPS. Now it's okay. This will be our backend endpoint. So we don't want to export it. We can disable. For validation, I'm just choosing DNS validation. For DNS validation, mainly we need to add some DNS record in our domain and AWS will verify it automatically. Let's click on request. So now here we need to add some values. Now as you can see here, it's showing pending validation. Now our domain has been added and certificate is also issued. We need to do a domain validation. Like here is the CNAME record. Let's just copy the CNAME name. Here let's add a CNAME record, paste it, just remove the domain name and now we need to paste our value. This one. Let's add this. Let's wait until the value gets propagated. So now our certificate validation was successful. Now here we can refresh it and here we can get our domain api.notes-app.snehasis.com. Here we are listening on port, target on port 80. Here if you want you can add some listener tags. Let's click on add listener. Now it's in progress. Now both are listening on target on 40. Now we need to do one more thing. So this was our endpoint. We'll be requiring this and here we'll add a CNAME record and the value will be of this load balancer DNS name. Let's add this. Now it's okay. Now what we can do, we can just test whether our value has got propagated or not. Let's try check it. So from here we'll check our DNS record that whether our api.notesapp has the correct CNAME value or not. So now if we try to access this endpoint, we are getting the record of AWS application load balancer DNS record. It means that we have successfully linked our API. Now, if we try to access this endpoint, you find that it's same, but this time we can also access this using HTTPS. Like you can see that we are getting a certificate. Let's try to go to /health and see. Now we are just accessing our backend endpoint and now we can use this endpoint to link with our main application that we have deployed. So everything will be completed now. Like if somebody by mistake access our HTTP record, then also it's working, but it should not. When we try to access HTTP, it should redirect us to HTTPS. So we can do this setup very easily. So for this, in this listener, the HTTP 80 listener that we have, we need to do one change. Like here, the rule that we have, we need to edit it. Instead of sending it to target 80, we'll redirect this to HTTPS. And port number will 443. It will automatically understand what to do. We don't need to do anything manually. Like if we try to access HTTP and send a request, we'll find that we are automatically getting redirected to HTTPS. Now you will find that if we try to access the production backend endpoint without HTTP, then it's automatically redirecting us to HTTPS. That's really a very good thing. Now the part that is left is linking with our production frontend with our backend. So this is our production backend URL and we have our frontend running in AWS Amplify. Let's open this in new tab. So here was our scalable notes app that we have deployed. Just open this. Here it was our production URL inside hosting, environment variables. This was our backend URL. We need to manage this and instead of this kernel URL, we'll be using this URL. Remove the slash at the end and now let's save it. It will not get automatically deployed. Instead, we need to just deploy our application. And we know one thing, it will be an automatic step. Like if we try to save this changes that we have done, like add a Docker script and load testing. If we commit these changes and sync with our GitHub repository, the front-end application will get automatically built and deployed. Just wait and watch. Like here, if we go to overview, here you can see that it's currently deploying. Let's wait until it gets deployed. So now our application has been deployed. Let's try to access our production URL. This is our production front-end application. Let's try to sign in with an existing account. Now, as you can see that it's loading the nodes and all these nodes are coming from our backend. Like as you can see, the api.nodesapp.snehasis.com this, and you can see that it's coming within 200 milliseconds of time. So this is our highly scalable nodes application that we have designed. Here we can create new node and add new node, and this node got added. We can view the node, either edit the node, and we can also make it publicly shareable like this. So I will not conclude the video here, but the most very important part is that everything is working fine, but one thing is that I cannot run this 24/7. It will cost me too much money and I'm not willing to pay that to AWS. And you should also not use this if you are not running your application for production use. For testing case, it's okay to test for 1 to 2 hours. After that, you need to terminate all the things. For this, let me show you how you can terminate. Here first, since we are doing everything inside our service, if we delete the service, automatically our load balancers, our target groups, our auto scaling and alarms, all these things will get deleted. So for this, just delete the service. I know it's hard to do, but since we are doing it for learning purpose, so we need to delete it. Let's delete it, and it will take some time. So the cluster does not have any additional cost, but the service that is running has a running cost, and I don't want to pay that cost. So for that reason, I just terminated the service. Now, if you want, you can delete the task definition that we have created, this one. It cannot be deleted. It can only be deregistered. Like we need to select this action, deregister them. Just click on deregister. And now all those are gone. If we try to refresh, you will find that that task definition is also gone. If you want, you can also delete this cluster. Now the task definition and the cluster does not have any additional pricing, but since we are deleting everything, let's get clean. So now everything is deleted. If we try to access this load balancer, now if you're able to see this load balancer, make sure to delete it because you don't want to use this load balancer. This load balancer also has additional pricing, so just delete this load balancer. It's okay, we can also delete our target group. Let's delete it. And inside our alarms that we have, this alarms get deleted automatically. Now we have just clean. This was just for a testing demo. For production use case, you should not be deleting it after doing all the tasks. But if you are doing it for testing phase, you should be deleting after your work is done. So that's all for this video. Now I hope that you'll be able to build your own production grade application and deploy it in AWS and add load balancer and auto scaling to scale it infinitely. So that's all, and thanks for watching and supporting the AWS tutorial series. If you want, you can also check out the other AWS tutorials. So that's all. Thank you and thanks for watching.